Hi, I'll be doing SQL in two parts. In the first part, we'll be discussing database terms and then looking at examples for structured query language. These examples that are done on an online platform are available for you as links in the description, and you'll be able to do these and practice them and change them for yourself without having to download the software. In the second part, we'll look at downloading MySQL and working in ideally with MySQL Workbench. We'll also work with SQLite using Jupyter Lab. We'll begin this part with an introduction to database concepts and its need. We look at relational data model along with table or relation, attribute, tuple, degree, cardinality, primary key, and data types for attributes. We'll briefly discuss structured query language and then look at examples for data definition language and data manipulation language commands for SQL. And we look at SQL operators and clauses such as where, like, between, order by, group by, having, distinct, and is null. We'll talk about aggregate functions, minimum, maximum, average, count, and sum with examples. We'll end the first part with an example to show equi-join and natural join using two tables. And here we'll also explain the concept of primary and foreign key. We start with data, which is information, facts, statistics, or knowledge represented or coded in some form suitable for better usage, processing, reference, or analysis. And in computing, data is information that has been translated into a form that is efficient for movement or processing. A database is considered as a container for storing data and for easy access and efficient manipulation of this data. Databases have been around for a long time, and every organization, however small or big, needs to maintain one. In current times, databases have become an asset that can help store vital information, make it extremely versatile to use, easy to access, and secure. A relational database management system, or an RDBMS, is a database management system that stores data in the form of related tables, which are also called relations. It is a software that executes queries on the data, including adding, updating, and searching for values and providing a visual representation of the data. Now, that brings us to the most important part of a relational database model, which is a table, and it's also called a relation. It's a collection of data elements organized in terms of rows and columns, and it's the simplest form of data storage, and it cannot have duplicate data. A single entry in a table is called a tuple or a record or even a row, and a tuple in a table represents a set of related data. A table consists of several records, and each record can be broken down into several smaller parts known as attributes or fields. The cardinality of a table or relation is the number of tuples it contains, whereas the degree of a relation or a table is the number of fields or attributes it contains. We look at employee record table to understand these terms better. We have a table which has four attributes: ID, name, age, and salary. Therefore, the degree of this table is 4. We also have 5 records, so the cardinality or number of tuples here is 5. Notice that each record has an ID which is unique. This is also called the primary key. Each item in this table is called a data item, and it's stored in bytes. Another important term is attribute domain, which defines the type of values a certain attribute can have. For example, name can contain only alphabets. You cannot put any numbers there. So this brings us to the data types of attributes. We're going to look at some of the most commonly used data types for attributes in MySQL. If the input in a particular attribute is going to be alphanumeric characters, we can choose char or varchar. Char fixes n bytes and the maximum length here is 8,000 characters, whereas varchar gives us the option of variable length with maximum of 8,000 characters. In case the attribute contains a number, we will choose the data type as int or integer, small int, bit, decimal, or float. Another commonly used data type is datetime, and depending on how we want to use it in our database, we choose datetime, or we can choose date, or we could choose time alone. We'll now look at structured query language or SQL, which is a language used to operate databases. Now, this includes creating a database, creating a table, adding data to this table, modifying or deleting data from a table, fetching or viewing data from a table, and much more. Structured query language commands can be classified into three groups: data definition language, data manipulation language, and data control language. Data control language or DCL consists of commands like grant or revoke. These commands are used to grant or revoke privileges from users on the MySQL server. We look at these examples in part 2 of SQL. DDL or data definition language consists of commands like create, alter, and drop. We're going to use this online platform with SQLite to demonstrate the SQL commands. We'll start with data definition language commands, that is create, alter, and drop a table. We start with create table, the keywords, and give the name of the table as student detail. It's up to us. Whatever name we want is suitable for the table, we give that as a name. In the brackets, we're going to give the names of the attributes and the data type of each. We start with admission number, which is integer data type. It is also specified as primary key. That means each time the admission number has to be unique. We have the attribute name, which is data type varchar. We have age, which is int, city, which is varchar, variable character. Then we have score, which is again an integer. We use the keywords insert into, give the name of the table, give the keyword values. In the brackets, we will give the values according to the data type that have been given for each attribute. And once we've inserted all the values in the table, we are going to now alter this table by using the keywords alter table, giving the name of the table, using the keywords add column, and then giving the name of the column and the data type of the column here varchar. We're also going to use this command to describe the table. We'll use the select command to view all the records from the table. We'll use drop table and the name of the table. And once we do that, the table will have been deleted. And if we try to see the structure or description of the table, it will not be able to show us. And if we try to view the records from the table, it will give us an error. So we execute this. We'll see that it gives us the description of the table, and it has also added a new column here, email, and of data type varchar. We try to output all the records from the table, and we've got all the records that we inserted. However, once we use the drop table command, we'll see that it gives us an error if we try to output the records, that no such table student detail. Data manipulation language or DML consists of commands like select, insert, update, and delete. We'll now demonstrate the SQL data manipulation commands select, update, and delete. We start by creating a table and inserting all the values in this table. We'll use the select command with an asterisk. So select star from student detail will give us all the records. When we execute, the entire table will be displayed. We can modify a record in the table using the update keyword. We use update. Student detail is the name of our table. We use the keyword set and we give it a condition to change or modify. Then we use the clause where to specify which record needs to be changed. So here we are going to give the condition as name equal to Aditi, and we are going to set the condition in that case as the age is equal to 17. When we execute, we'll see that now the record where the name is Aditi has changed the age from 19 to 17. To delete a record from a table, we use the keywords delete from, give the name of the table, use the clause where, and give the condition which will specify which records to delete. So when we say delete from student detail where age equal to 17, then when we execute this, we'll notice that all those students whose age was 17 are no longer part of this table. To view specific records, we can use various operators and clauses with the select command. We see some examples here where we are going to use some comparison operators, logical operators, and some other clauses. So in the first example, we see we are going to select all records where age is equal to 17 or the score is greater than 400. So when we execute, we'll see that all records either have age 17 or they have the score greater than 400. In our second example, we are going to use select with the comparison operators and logical operators and not. So we say select star from student detail where age equal to 17 and not score greater than 400. When we execute this, we'll get only those records where the age is 17 and the score is not greater than 400. In the next example, we are going to use the clause like. We're going to say select star from student detail where score like 3%. That means that it should start with 3. It can be followed by any other number. So when we execute this, we'll see that the output will have all scores which begin with 3. In the last example, we are going to output all those records where in student detail, the score of the student is between 350 and 410. So when we execute this, we'll get all those students whose score is between 350 and 410. We look at more examples where we're going to look at clauses like order by, group by, having, distinct, and is null. We'll use the same table that we were using before, that is student detail, and this time we're going to discuss the clauses order by, group by, distinct, and having. We start with the order by clause. We're going to select name and city from student detail and order by city. When we execute, we'll notice that the cities have been grouped together and it has been output in the ascending order of cities. We'll now look at another example where we are going to order by city, and this time we are going to select distinct city. When we execute this, we'll notice that it's going to output only the city names and they're going to be output in the ascending order. In the next statement, we are going to output city and score, and we're going to order by the score. This time the output will be in the descending order. We'll see that the highest score has been placed on the top. At the bottom of this output is the score which is null. We're now going to select the city and the sum of the scores from that city. We're going to group these by the city names. If we execute this, we'll see that the output has grouped the cities with the sum of their scores. In the next statement, we are going to output the name, score, city, and age from the table student detail. We're going to group this by score, and we're going to further filter it using the clause having, and we're going to mention the condition score greater than 400. When we execute this, we'll see that all those students whose score is above 400 have been placed in this output in the ascending order. In the next statement, we've output the name, score, city, and age again from the table student detail. We've grouped it by score, and we've used the having clause with city in Mohali or Chandigarh. When we execute this, we'll see that the output is only for the cities Chandigarh and Mohali. Another important thing to remember is that the having clause always follows the group by clause. So whenever we need to use having, we have to place it after the clause group by. In the next statement, we'll output the name and city for the candidates from the table student detail where score is null. When we execute this, we'll see that there's only one candidate whose score is null. We'll now look at some more examples where we're going to use the aggregate function. We're going to quickly look at the sum, average, minimum, maximum, and count functions and how they can be used in SQL. So we start by selecting the sum of the score from the table student detail. Then we're going to output the average score from the table student detail. We'll also output the average score where the age is less than 18. We're going to output the minimum score from the table. We'll also output the minimum score where the age is equal to 17. We're going to output the maximum score, and we're also going to output the number of students who have scored greater than 450. So when we execute this, we'll see that the output for the sum of the scores is 4074. The average is 407.4. The average of scores for age less than 18 is 398.6. And the minimum score is 342. The minimum score where age is equal to 17 is 345. The maximum score in the table is 476, and the number of students who've scored more than 450 is 3. We'll now look at an example where we're going to use two tables, the student detail table and the sports team table. In student detail table, we'll have the admission number as primary key. This will also be available as an attribute in sports team, the second table. And here it will be called the foreign key because in sports team table, the primary key is sports ID. Let's take a look at the example. We're now going to look at the equi and natural joins using two tables, the student detail table and the sports team table. The student detail table has the admission number as primary key, whereas in the sports team table, we have sports ID as the primary key. However, there's also the admission number in sports team, which is the foreign key for student detail table primary key. And this is the field which is used to create a relationship between these two tables. Now we're going to use this statement to join these two tables. That means we're going to select everything from both student detail, comma, sports team, where student detail dot admission number equal to sports team dot admission number. So when we execute this, we'll see that in the output, all the admission numbers that are there in the sports team are displayed in the output. Now, you'll also notice that the fields from both the tables have been displayed. That means all the fields from sports team and all the fields from student detail have been displayed in this output. Another way to use the equi join is using the keywords join and on. We say select star from student detail, join sports team on student detail dot admission number equal to sports team dot admission number. When we execute this, we'll notice that we got the same output as before. So these two statements are the way in which you can write an equi-join. For natural join, we can use the keywords natural join in the statement. We say select star from student detail, natural join sports team. When we execute this, we'll see that the natural join gives only the common fields, that is, only the fields that are common to both the tables, and it does not repeat the output from both the tables. So this is a better option for a join. So that brings us to the end of part 1. And I hope you've understood the examples that I showed you. You also have the option of looking at them again with the links in the description. My advice is you can practice this. You can also make changes on this online platform and create your own examples. You can then put them in your practical file. There's also more code available in part 2, which I will be doing later. So I hope you'll continue watching. Bye bye.